Hello everyone. Welcome to the video lecture series of data structures. Today we are going to learn about the stack applications, the other part which is known as, today we see about the decimal to binary conversion and reverse the string topic. These both are the stack applications. Hi, this is your instructor Janice Shah. So let's begin with our first application, that is known as decimal to binary conversion. Students, you already know about how to convert the decimal to binary. It might came in your digital electronics subject. Okay, so it's not like the similar, but yes, answer is similar. We have one unique method which is implemented by stack. So by using stack, you are going to convert this number into binary. Okay, so let me show you how. Step. So first, students, you just need to divide your number by 2. Whatever the remainder you get, you need to put inside the stack. Okay, whatever the remainder I get after dividing this number by 2, you just need to put inside the stack. Then do this step until and unless you'll get 1 as a quotient, and then students, after this, pop each and every element from the stack. That's it. Whatever the answer you'll get after popping the element, all the answer will be merged together. Okay, and then it becomes a final answer of decimal to binary. Let me show you how we're gonna take this place. So here it is. First number, students, we have the 12 with us. So first, do not forget, see, I'm going to take hash on, I'm going to initialize my stack with hash. This hash shows the starting point of the stack. Okay, so whenever I'm going to try to just take out the numbers from the stack, whenever I get hash, I stop my operation from that. Okay, so I'm taking initialize my stack with hash. Okay, we already did such type of things in your infix to postfix expression where we used to initialize our stack with hash. Fine. Okay, so I'm going to do the same thing over here. So first step is initialize the step by hash. Now take the number 12 modulo 2. Reminder, students, is 0. Reminder is 0. Push the remainder inside the stack, that is 0. Next, whatever the data you get, there is 6. So 6 modulo 2. 6 modulo 2. Again 0. Push inside the stack. We get 3. Next, 3 modulo 2. It gets 1. Again push inside the stack. Now, after 3 modular 1, students, what do we get? We get 1 modular 2. 1 modular 2. We get 1 again. So this is our last step. Fine. Okay. So this is our last step, students. We already get, whenever you get 1 modular 2, then you just need to stop over there. So whatever we get, we just need to pop it out and then append all of them together. So first we get 1, 1, then 1, then 0, 0. So 1, 1, 0, 0. If you know how to convert this into the binary, you will also get the same answer. See, I just need to convert this binary to decimal. How? This is first 0 represent 2 raised to 0, second 2 raised to 1, both gets null. Third one become 2 raised to 2, it is 4, and fourth one become 2 raised to 3, that is 8. So 8 plus 4 becomes 12. So you have your answer. Fine. So isn't it easy to convert your decimal number to binary using stack? Let's take a look at another example. Students, right now I have the 102 with me. So first initialized with the hash. Okay, now let's start dividing this, getting the remainder, push the remainder inside the stack, and repeating this step until unless you get 1 with the quotient. So let's take a look at it. So first we have the 102. 102 modulo 2 becomes 1. Oh, sorry, 0. So we just need to push inside the stack, that becomes 0. Next we have 51. So 51 modulo 2 becomes 1. Push inside the stack again, it becomes 1. Next, students, we have 25. So 25 modulo 2, that returns 1. So push inside the stack, it is again 1. Now 12. So this is the same procedure which we have already done before. So 12 modulo 2 becomes 6. Sorry, 12 modulo 2 becomes 0. push the 0 inside the stack. 6 modulo 2 becomes 0, push the 0 inside the stack. 3 modulo 2 becomes 1, push inside the stack. 1 modulo 2 becomes 1, push inside the stack. Now stop. This is the last step, that 1 modulo 2 is equal to 1. You need to stop over here. Fine. Okay. So what the left over there? We just need to push each and every element from this. So first we will have 1, 1, 0, 0, 1, 1, 0. Then append together, this becomes the final binary. If you just calculate the decimal number from this binary number, students, you will get the metadata that you already have your answer, which is like, see, 64 plus 32 plus 6 becomes 102. So fine, you get your answer. Such like this, students, you can convert your decimal number into binary. Now let's take a look at the algorithm how to convert the decimal number to binary. Students, what we did first initialize the stack with hash. It helps us to get back the values easily. Fine. So first initialize the stack. So top arrow 1, s of top is equal to hash, and then answer is equal to null. Why I took the answer? Answer contains all the appended values. Okay. Now next, students, we have take the new data. So number arrow new data. Students, here the new data is nothing. The data inserted by the user is stored in the number variable. Okay. If you have entered 102, now number contains 102. Now next, apply the division and remainder method over here, students. So first repeat while until and unless your number it becomes 0. Okay. See, if a number is not equal to 0, then you need to repeat this process again and again. How? Let me show you. Let me show you with the example of 12. Okay, fine. Students, first we have the 12 with us over here. Over here we have the 12. Okay, now remainder is equal to 12 modulo 2. It becomes 0. And number is equal to number divided by 2. It becomes 6. So what we need to do? We just need to push into the stack remainder. So I have already pushed 0 in the stack and repeat this process. Repeat this process. So now my latest value of the number is 6. If you remember, latest value of the number is 6. Okay. So with the 6 value, I again go inside the loop. 6 modulo 2 becomes 0. Number becomes 3 because 6 divided by 2. It becomes 3. Okay. So again I need to push. I get 0 over there. Again go inside the loop. Now 3 modulo 2. 3 modulo 2 becomes 1. Okay. And 3 divided by 2. 3 divided by 2 becomes 1.5. So number in number I have 1. Okay. So again I need to push 1 over there and go inside the number. Now in number I have 1. So 1 modulo 2 students becomes 1. And 1 divided by 2 becomes 0.5. Students, it is an integer number. It is an integer number, so it becomes 0 automatically. So you are just need to push the last remainder over there. Now the latest value of the number becomes 0. So number is not equal to 0, condition get false, and you stopped over there. Fine. So what we have left, just we get all the values over there. We just need to pop out all of them, concat into the temp, and get the answer. So this is what we have. Repeat while until and unless you will get s of top is not equal to hash. For this condition, I took initialize my stack with hash. Now temp arrow pop s comma top, whatever the element I popped out from the stack is stored inside the temp and then appended with the answer. So answer is equal to answer concat temp. Okay, so that's it, students. This is all about the decimal to binary conversion algorithm. Now you just need to write down an answer and you will get whatever you want. Next we have how to reverse the string. Let me show you. See, the reverse the string is little bit similar to decimal to the binary. Fine. Let me show you how it is possible. See, the reverse the string, here we are going to take initialize our stack with hash same as the previous one. Okay. Then just imagine our string is equal to data. String is data, data. Now how to reverse it? Let me show you. See, first append hash at the end of the string. So it goes like this, data hash. Why I am taking hash? Hash just represent end of the string. Okay. Now let me take one stack, initialize stack with hash. Now I'm going to take each and every character from the string until and push inside the stack until and unless I'll get hash in the input string. Okay, clear? So first I'm going to take the D, push inside the stack, then A, push inside the stack, T, push inside the stack, A, push inside the stack. Now students, the value, okay, it becomes hash. So now I'm not going to take that hash over here. Okay, so what I have A, T, A, D and hash inside my stack. Now what to do? After push, you just need to apply the pop operation and concat each and every word. But do the pop operation until and unless you will get hash value. That's why I initialize the stack with the hash. Okay. So first we get, so students, first I'm going to apply the pop operation. I get A, then I get T, then I get A, and then I get D. So it becomes A, T, A, D. Okay. So what happens over here? After applying the pop operation, my whole string is now available in the reverse form. So that's it. Isn't it easy? So let me show you the algorithm for this. Students, the algorithm is most probably the same as the decimal to binary conversion algorithm. But here, let me just inform you something with some functions which we have already used in our infix to postfix algorithms. So here students, I am going to use the next character function. Next character is a function which returns the next value from the input string. Okay, here I have the reverse. Reverse is my output string variable. Then I have the input. Input is my input string variable. Okay, so let me show you how we can do this. So first initialize the stack with the hash. So top is at 1. Okay, s of top is at hash. I have already initialized it. Now next, let me initialize the reverse string. So reverse is the final string which contains our answer. So I have initialized with the null. Now next is get the next character. Our first step is to take the one character from your input string. So just apply a function next arrow next character of input. If you remember the next arrow next character of infix, this function is doing the same work, and that algorithm infix to postfix, we are extracting the expression values. Okay, each and every character values from the expression. But here we are extracting the each one by one character values from our input string. Now we have next arrow next character of input. Okay, so what to do next? Insert into the stack and get the next character value. Okay, we already get the one value. So now our what is our duty? Our duty is to push this number into the stack and again go back to take the another value. So here we have students repeat while your next is not equal to hash. Fine, that's why I put hash over there. So repeat while your next is not equal to hash. What to do? Just first push your previous number, your previous next value inside the stack and get the another one. So I just call push next over there, and then next arrow next character of input, I call this function again to take the next value. So just imagine our previous example, we get the D, okay, push the D inside the stack and then get A, check the condition, is A is equal to hash, no, push the A, get T, check the condition, is T is equal to hash, no, push the T, get the A, check again, push the A, get hash, check again, hash equal to hash, the condition match, now it will be stopped. So in stack we have D, A, T, A. Okay, so what to do next? We just need to remove the element from the stack. Okay, so for that we apply the pop operation. So pop s comma top, it will store into the temp. So in temp first we get A, concat with the reverse, so reverse becomes A. Next we get students what? A, T, A, D. In the similar type of steps, each and every step this loop is going on until unless s of top becomes hash, and we'll get our answer. The final thing is just write reverse answer. So isn't it easy, students? Right? Such like this, students, stack is very much useful in our day-to-day life. This is the application of the stack. Today we learned about the applications of another two application of stack. One is reverse the string and second one is decimal to binary. We'll see the more application of stack in our upcoming lectures. Okay, still if you have any doubt then please feel free to ask me. Thank you so much.